All right. That's absolutely. So chapter 13 is all about factoring. Factoring is usually the next hardest topic for students. And it's really just what makes multiplication challenging is, sorry, factoring challenging is not knowing your multiplication tables. So what you have to do a lot of times is look at some numbers and go, what numbers go into this? Is it, and then you have to ask what's the greatest number that can go into it. So for instance, if I say 6 and 18, a lot of students will tell me, oh, well, 3 goes into it. Yes. But what's the greatest number that would go into 6 and 18? And that would actually be 6. And so they struggle a lot of times with your multiplication tables. So if you struggle with your multiplication tables, that is why factoring will be hard. Other than that, factoring is one of the things you'll continuously see throughout the rest of these chapters, and all in college algebra and anywhere else you go into your math. Right? But what factoring does, it helps us just kind of take those long polynomials and basically when we started multiplying, we had like the two binomials and stuff like that. And then we would work it out and have a trinomial. So now what's going to happen is I'm going to give you a trinomial and you go backwards and you give me the two binomials. So basically we're doing like reverse multiplication. All right. So chapter 13.1, we're going to talk about the greatest common factor and factor by grouping. So greatest common factor, which is also going to be denoted with GCF. So you ever see GCF, that's what it stands for. And factor by grouping. Least common denominator, that's the one. Which is crazy because usually your greatest common factor is actually a relatively small number, and your least common denominator is actually relatively a big number. So those words are usually kind of misconceptions there. All right, so let's get into our first one. You're going to be asked to find the GCF of a set of numbers. So here's our first example. 5, 10, 20. What's your greatest common factor? So greatest common factor would be a number that can go into all three numbers. 20 cannot go into 10 and 5, but 5 can go into 5, 10, and 20. So here's the rule of thumb that I teach kids or students, because they're not kids. Start with the smallest number that you see, and then ask, does that go into the other numbers evenly? If so, that's going to be your answer. If not, you then need to come up with a couple of numbers that would go into that number. And right. So let's say that was like a 6 or something like that. Then you would go 2 times 3 and go, all right, well, 2 can go into 10 and 20. Yeah. No, you're good. But that's kind of how that concept would be. So yeah. So if this said hypothetically 6, 10, 20, 6 would no longer be the answer because 6 does not go into 10 and 20. So I would then take 6, break it down into 2 and 3, because that's what would multiply to 6. And then I'd ask, well, does 3 go into 10? No, so that one's out. Then I would go, does 2 go into 10? Yes. 2 goes into 20? Yes. So therefore, 2 actually becomes the greatest common number that 6, 10, and 20 would have in common. Right. So it's greatest, but a lot of times it ends up being one of the smallest numbers or smaller than the smallest number you see. Where least common denominator was either the largest number or something even bigger than that. All right, let's look at this next example. 150 xy, 250 x cubed y squared, 100 x squared y squared. That's it. Start with the numbers first. Let's look at 150, 250, and 100 and ask ourselves what would be the greatest common factor? Oh, sure you don't want to stick with 50? Okay, you're correct. So you would want to start at 100, but 100 does not go into 250. So then we break 100 down and we say, well, that's the same thing as 2 and 50. So then we go, does 50 go into 250? And does 50 go into 150? Yes. So therefore, 50 is the greatest common factor. So even though the number's not there, we start with the smallest and then go down to its factors. So like I said, what makes this challenging is if you struggle with the multiples. Very good. So what you do now is you notice that they all have an X? Okay, so we can always pull out at least one X, but then you're going to go to the smallest power. What is the smallest power out of the three options? It would actually be one. Those are coefficients. The 100, the 250, and the 150, those are coefficients. The powers are these little bitty numbers. There you go. So typically, yeah, so perfect. So the smallest power is the greatest that you can take out. One if you wanted to write it, but we don't write the one. What about the y's? Do they all have a y in there? All right, so I'm going to write the y. What's the smallest power this time? One again, because I got a two, and then I got a one. So the largest amount that I can take out of everything is just one y. And so there you go. That would be your greatest common factor. So the way I do this is I separate it. I look at the numbers first, then I'll look at all my letters and just kind of go down from there. Rather than looking at them all together at once, it's a little overwhelming. What is it called again? Great, powers or exponents or degrees. Yeah, no, the powers, exponents, degree. I mean, any one of those three words all mean the same thing. The little bitty number. All right. Ain't no problem. All right. So let's look at it in this sense. So number two, we're going to factor out the greatest common factor. So we have 7n plus 21. All right. So I'm looking at it instead of terms separated with commas. I now have a binomial or potentially a trinomial or whatever the situation might be. And I want to go through that same process. Looking at the numbers, what does 7 and 21 have in common? 7. Right. 3, right? Perfect. So therefore, I'm going to write my greatest common factor down. Now, I noticed that this has an n, but did this term have an n? No, so there is no letters in common. Now, here's where it gets tricky. Questions on how I just came up with 7 as my greatest common factor. Goes into 7 and 21, right? Here's the next step to factoring. Now that you determine the greatest common factor off of 12.8, now you have to divide the greatest common factor to figure out what is going to be left. So you open a set of parentheses, take this greatest common factor we just determined, and now I'm going to divide each term by that greatest common factor. So what is 7n divided by 7? 1n. Very good. Just put in. Plus 21 divided by 7. 3. Now, to show that I did this correctly, going off of chapter 12, I could distribute this 7 back, and I should get my original answer. So 7 times n would be, and 7 times 3 would be, so I know I did it right. Parentheses n plus 3, the whole thing. Let's try another one. So we have 3y cubed plus y to the 4th. They got any numbers in common? Not in this case. I got a 3, and then the other term don't even have a number. So I have no numbers in common. Do we have any letters in common? Yes, I have a y. To figure out how many y's I can pull out, what do I look at again? The exponent. Which one's the smallest exponent? 3. So I can take y to the third out of each term. So now that we've determined my greatest common factor, to figure out what goes in the parentheses, I'm now going to divide that greatest common factor to each term. So in this situation, what is 3y cubed divided by y cubed? This would cancel, so it'd be just 3. And then what would y fourth divided by y cubed be? So the y cubes would cancel. That would become 1, but the 3 was still there. So it'd be like 3 times 1, which is 3. Correct? Good. So then it would just be plus y to the 1 power, but we don't have to write that. And there you go. All right. Let's try another one. 9x plus 54x squared. Yes, it does. So therefore, my greatest common factor for my number would be what? 9. You're thinking of the result, but 9 itself is what I would take out of both. There it is. So they both have an x in common, and the exponent there of 1, that's what I can pull out. Okay. So now you took the GCF 9x out. Okay. When everything cancels, what's left? What is 9 divided by 9? 1. So if all the numbers and all the letters cancel, there is still a 1 left over. This one you do because there's no letters left. And then what is 54 divided by 9? 6. Ooh, what's x squared divided by x? Just an x, because 2 minus this imaginary 1 would be 1. So I'd have 1x. And again, if you're ever unsure on your math, you just distribute that back, and you'll see that you go back to the original question. If you didn't, then you did something wrong. All right, are we okay with this right now? Okay, just like the homework's been doing, let's progressively get a little bit harder. So again, we're going to factor out the greatest common factor of a trinomial. So we have a 6x squared plus 2x minus 9. Really? Okay, there. What is the greatest common factor here? Okay, let's look at that. 2 does go into 6, but does it go into 9? Can 2 break down any further? Well, you can always take a 1 out, but that doesn't change anything. So other than that, does they have any numbers in common? No. What about letters? Okay. This one had an x. This had an x squared. How many x's does this one have? There is no x's there. So they have no x's in common either. So no number. So no number and no x means it's not factorable. It has to come out of all terms given. So if we backtrack this a little bit to this right here, when I had 3 terms in parentheses, For me to have a GCF, it had to come out of all three of them. Now, this one with the same three, they have no numbers or letters. So when that happens, and this does happen on your homework, you would check the box that says not factorable. It's literally going to be like, it's going to have an answer choice box or a little click thingy. No. That's okay. It's just that the 9 does not have an X at all. You have to find a greatest common factor in all three terms. So even though these two right here both share a 2X and a 2 and an X, but the 9 shares nothing. So therefore, nothing shares anything. It has to come out of all terms. So let's look at one where it's not factorable. So let's look at negative 9a cubed minus 18a plus 9a squared. I do agree. 9 goes into 18 and 9. And there's an A. What was your question? You can, but you're going to have to go back and divide it by the GCF. So I think maybe crossing out, you might lose some numbers. Just know that you're focused on the numbers first, and then you just go down the letters. Or if you wanted to rewrite it or whatnot. One more time. Yes. So what's the largest amount of A's I can take? What's our smallest exponent? Just one. The imaginary one. So the 9A is the biggest I can take out. So then I go and I divide every term by that greatest common factor. And by the way, this is a 9A, not a 9 and a littler 9. So then what is negative 9 divided by 9? Negative 1. That would be adding. So in this case, you would do 9 divided by 9, which is 1, and then a negative and a positive makes a negative. Again, you don't typically write the 1. So then a cubed divided by a would be negative what? Okay, negative a. Negative a squared. Square, very good. Yes, ma'am. You good? So negative 9 divided by 9 is negative 1, but we don't have to write the 1. And then when I'm dividing exponents, I subtract the exponents. So 3 minus 1 gives me 2. And then I keep going. So the negative 18 divided by 9 would be negative 2. A divided by A would be nothing. They actually cancel. So then I have a plus. 9 divided by 9 be 1. And then A squared divided by A would just be A. Now on this one, you actually have two answers that you could have chose. I think the homework accepts both of them, to my knowledge. If the leading term is a negative, you can actually factor the negative out with the number. So another answer that you could have gotten is negative 9a, and then you would have changed all the signs. So this negative would have been a positive, this negative would have been a positive, and this positive would have been a negative. So when you're trying to do it, and it tries to help you and guide you through the problem, a lot of times, a lot of mathematicians just don't like the first term to be negative. So they'll also factor out the negative so that the first term isn't. I'm good with either one, and I'm almost 98% positive it takes both of these as an answer. We good? Okay. Okay, so let's do some more like this one. So look at number 5. A 10xy plus 30xy squared. Perfect. Mm-hmm. Good. Oh, he just told me to carry over the xy, then he was telling me the exponent, so I was letting him go. I'm done. Because both the x and the y, smallest exponents, both happen to be one. That happens, yes, to be that, but that wasn't what I wasn't just trying to write the answer. You said carry over the x and the y, and I did. And then I was letting you go with the one. So processing through it, they all have an x and a y. So I did. That's good practice. Write those over there, and then you look at the smallest exponent. Oh, this? Well, now that I have the GCF, now I can divide all of them by that GCF. Good. So 10x and y would all cancel, leaving me with just a 1. 30 divided by 10, 3. What happens to the x's? And what about y squared divided by y? There's the y. So that's what you do with the square when you go back and you divide it. Okay, that's pretty good. I feel like y'all did most of that. Let's see if y'all can get to the point to do all of it. So let's try this one. 2a squared b squared minus 16ab squared. Okay, I agree. Ooh, I agree. So the 2 is the smallest. It goes in the 16. They both have an A. A is 1 is the smallest exponent. But for B, both B's both have a square. So the square would be the smallest because they both have the same thing. Does that make sense? Yes. Okay. So now that I have it, now I can divide. So what happens to the 2's? Cancel out. A squared divided by A. 1A, good. What happens to the B squares? Negative 16 divided by 2. Good. Bring over the sign with it. Good. So that minus will go with it. What happens to the A's? Cancels out. B squares? Cancel out. So there's your final answer. We good? All right. Let's try another one. This 2 on this right here. On this one. Yeah, the B squared and this B squared, 2 minus 2 would be 0. So they would zero each other out. You're welcome. So we have 5xz squared plus 15xz cubed minus 20x squared z. Yeah, so that's a, I don't know, that's a bad z, but oh, minus 20x squared z. Greatest common factor, but yep, you're good. So 5 and Very good. So there's only one X there and one Z there. Not anymore. Yeah. Because you're basically doing reverse multiplications. All right. Two's here. Yeah, the smallest one. So since one is the smallest, I'll carry that one. And since that one was the smallest, I'll carry that one. Yeah, it's always going to be the smallest one. But then now you take that and now you have to divide each one. Mm-hmm. So the 5 would cancel out, yes. Cancel out. Good. So z squared divided by z, there'd be 1z left. Three. Very good. Very good. Good. 20 divided by 5 is 4. Very good. There he is. All right. Let's try this next one. Negative 3b squared d plus 12b squared minus 15b cubed d squared. I have no idea. I try to produce my own and they never work out. There's like fractions involved, and I'm like, I didn't mean it to be this hard. I will say what they a lot of times what they'll do is they'll take a multiplication problem, know what the answer is, then get that answer and go, all right, here's the answer, and I know it's going to look like this one. So like reverse, do the problem. Okay, I like the -3 approach. B too good because it's 2, 2, 3. 2 ends up being the smallest. Good, and this is 1. Ooh. There is no D in the middle, but I almost went with it because I was thinking it was a square. There is no D in that middle term, and I didn't misdo it. So there, I cannot take a D out on that one. So then I take that and let's divide it. And this here are 3 B's, not 36. Good, the 3's would cancel. The B's would cancel. In that case, it would just be a D. Close. 12 divided by -3 is good. -4. You're good. And then B squares would cancel each other out. Two negatives make a, so +5, good. Very good. 3 minus 2 would be 1, so you'd be left with a B. And then I still have D squared. This seems like a great intermission. Absolutely. We were invested. Should I have an event today? Oh, yeah. Thank you. Hey, That's very good. Yeah, I like salty. Mm-hmm. All right, so let's kind of change the game. I still want you to factor, but now it's going to look like this. X squared, 2x minus y plus 2 times 2x minus y. And but the question hasn't changed. The question's still asking, factor out the greatest common factor. But what would the greatest common factor be in this situation? Maybe. On to something. Any other ideas? I mean distribute? I would not. So if we look at it individually, this is one term and this is one term. Out of those terms, what do they have in common? Part of it. Part of it. Part of it. You're on to something there, but you're saying all the right things, but not together. So that's it. They both have a 2x minus y. That is a greatest common factor. So I'm going to write 2x minus y as my greatest common factor. Then I'm going to divide by 2x minus y. And what's going to happen to my 2x minus y's? They're just going to cancel each other out. And what will I be left with? There it is. So even though the game changed a little bit, that's it. That's it. That's how I say it. Write it down once, write the leftovers. That's perfect. As the homework, yeah, you'll get a question like this, and then that would be the end result. Like the parentheses? Oh, maybe it's like the calculator, but it doesn't like the commas. I know on your calculator, you try to put the commas and it didn't say it, but maybe the program didn't want the commas either. Yeah, that's weird. With no commas. That's hard for me, like to understand the number because I have to like look at it and go, how many 3 sets am I in the millions, billions? All right, let's try another one like that. This is actually part A. Part B, 6y x minus u plus x minus u. Mm-hmm. Okay. Perfect. That's it. So what happens to those x minus u's? They go away. So in parentheses, what do I have left? There's a 1. Remember, if everything gets canceled, don't forget a 1. That's what's going to get us. Yeah, plus 1 in this situation, yes. Yep. And it happens. It happens. All right. So that's a lead way from GCF to now factor by grouping. Factor by grouping is a great tool to have when you have 4 terms. If you have less than that, we have other techniques. And if you have more than that, well, now you're talking about pre-cal. So 4 terms is how we do the factor by grouping. So we have xy plus 2y plus 6x plus 12. I will tell you this, as we learn more techniques, don't forget the techniques. So we just learned greatest common factor. So looking at this, is there a GCF in these 4 terms? No, but always ask yourself, because that's going to be a part of the question. So this is how you factor by grouping. We can't see orange. We're going to group up the first 2 terms, and then you're going to group up the last 2 terms. That's step 1. Put parentheses around the first 2, then put parentheses around the last 2. The second step, you're now going to find what the greatest common factor of the first 2 are, and then do the same thing for the last 2. So just looking at xy plus 2y, what do they have in common? Okay, so I'm going to write a y. That's my GCF of the first 2. So then in parentheses, I'm now going to divide each one by y, and what will be left? Oh, I'm not over there yet. What's left of this? There we go. So the y's would cancel, so I have x plus 2. Then you're going to do the same thing with the second or the last 2. What does 6x and 12 have in common? 6. That plus sign, bring it down with it. So plus 6. Now in parentheses, I now have to divide both of these by 6. So it's basically like doing 2 of those GCF problems in one. So 6x divided by 6 is x. And then 12 divided by 6 is plus 2. Okay. Now, this looks exactly what we just saw in the last 2. What is now my greatest common factor? There it is. So now I have to divide each one of those by the x plus 2. So then I have y plus 6. That's it. Which we now have the problem that we started with at the conclusion of Monday, right before we did the box method. We start with those 2 to get to that end result, and then now we're back to it. There is a process to them for some of them. I find the box method in reverse a little harder because you're having to guess numbers, but we can definitely try it. I got a different technique that I think is a little bit easier. And I think the book has like 15 different ways to do it. So I will say there are a lot of techniques when you are first learning factoring. Just pick one you're comfortable with. You don't have to know them all. All right, let's look at this one. XY minus 3y minus 2x plus 6. What am I going to do? All right. Now notice this one does have a negative right here. So what I'm going to do is I'm going to put a plus sign and put the negative on that one so that I can have that minus sign in the grouping. So anytime you have a minus sign there, just make it a plus and then attach it as a negative. All right. What does then xy minus 3y have in common? The y's. Perfect. So then I'm going to divide them both by y's. Gotcha. So when there's a minus sign, when you're trying to group them, just make it a plus sign and put the negative with the number. Because if you leave it as a minus sign and then you group them, now you've changed the value of this number over here as well. So what does negative 2x and 6 have in common? The 2. Oh, I didn't finish this problem. Oof. Xy divided by y. Just x. Very good. And then 3y divided by y. The negative 3. Perfect. All right. So again, so back over here. So negative 2x and positive 6 have a what in common? Good. Because the leading term is a negative, you want to factor out that negative 2. Because now I pulled out a negative 2, the plus sign basically the plus sign is there, but then a plus and negative makes a negative, so it stays negative. You're good. So then, so negative 2x divided by negative 2 would be x. Very good. And then 6 divided by negative 2 would be negative 3. Perfect. And then what? Perfect. There it is. We okay? We got plenty of examples. Go ahead. No, oh. I tell my high school kids, or I guess I did. Oh, I gotcha. If your brain doesn't hurt when you leave my classroom, I've done you a disservice. This should be like a workout, like when you're in the gym. If you don't leave the gym and you're not sore, you haven't improved your brain muscles, right? Yeah, take a breather. All right, let's try this one. So 2x plus 6 plus xy minus x squared. Oh, that's a 9. Sorry, number 9. I was too. I was like, hey, no, those are x's. I got you. Xy minus x squared. Mm-hmm. Correct. So what's the common in the first one? 2. So then 2x divided by 2 would be good because the 2's would cancel. So this be x. And then 6 divided by 2 would be 3. Mm-hmm. All right. What's xy and x squared have in common? X. So I bring that plus side down. So x. So xy divided by x would be y because the x's would cancel. X squared divided by x would be good, just an x. It's going to be 2 minus 1. Well, hold up. These don't match. When this happens, not factorable. These two binomials here, the x plus 3 and the y minus x, if you saw beforehand, they were always the same. Then we can keep going. When they're not the same, it's not factorable. So we can't go any further. Until we got to that point, correct. All right, try this one. Number 10. X squared plus xy plus x plus y. I gotcha. No, I know. Always trying to throw a curveball at you. When you group up the first two, x squared and xy had what in common? The x. X squared divided by x is good, an x. And then the y would cancel, so you do get plus y. Now you do look at x and y, and they do not have anything in common. earlier I told you, no, I'm not even say that part. If there is nothing in common, I'm just going to bring it down. So now, what's the greatest common factor? The x plus y. X squared divided by x, that was 2 minus 1. So it gave me just 1x. So that goes away. So, okay, I got an x. And then everything cancels here. There you go. Don't forget the 1. You're welcome. All right. Almost fell for it, but you didn't. So that was perfect. We're getting it. All right. I think this is the last one on this section. We'll take a little break. See how you do. All on y'all. 8xy minus 6wy minus 12xz plus 9wz. All right. What's the GCF in the first two? I would say 2 as well. Gotcha. Are you saying why, or like why is it 2? Okay. Okay. All right, so then I divide by 2y. So 8 divided by 2 is, oh, perfect. You got it. 4x minus 6 divided by 2, 3. Good. 3w. What does negative 12xz and 9wz have in common? It will be 3. Positive or negative? Negative. Remember, there's a leading term that's negative. You want to factor out a negative. What else? Z. So negative 12 divided by negative 3. 4. And then the z's. So just stuff with x. And then 9 divided by -3. -3. Z's cancel out, and I'm left with w. So then now what can I factor out? There it is. And then what would be left? Oh, don't forget this part. There you go. If you still need to write it on there, do that so you can see it. There you go. All right. I say we take a 5-minute break.